Hey, how's it going, guys? So here we are back again for Open-FDD. Just a little bit of updates. I want to tell you about the project, where it's at, and then today I want to run an experiment on how you can do fault detection on your own. If you can pull down from your IoT service provider bulk datasets in CSV format, or if you can pull it from the building automation system itself, how to run some basic fault rule equations across the historical data sets, where I'm going to task ChatGPT to use Python. So this is a bit of an experiment and it might not work. But it's I think it's worth documenting on YouTube, where we're at in the state of what the AI agent can do for you. So just a little bit of updates first on Open-FDD. It did have the concept idea in Python in version 2 was successful. And now cutting it over to Rust, it's going very slow. So slow that there's so many bugs to work out that the project used to be in a beta, kind of ready for people to prototype and test, but I'm putting it back to alpha because there's just so many bugs that trying to comb out on a daily basis that it is getting nightly builds, nightly tests, and it'll soon go back from alpha to beta to stable, but it's just not there yet. It's not a usable tool yet, but it will be soon. But today I just wanted to make a demo on how you don't even need Open-FDD to run fault equations across historical data. So let's demo that here now. So just for starters is there is documentation still. So there's what I'm trying to do is a community-based fault detection expression rule cookbook. This is some of the Docker information on Docker containers for the future, but just go to this blue button right here that says documentation online for Open-FDD. This is documentation hosted by GitHub. And if you go down to this DataFusion SQL rules, that is future SQL rules to do fault detection in Open-FDD. As soon as it's stable, it'll be DataFusion SQL. So it might even be useful if someone is already interested in doing fault detection with whatever SQL database they have. So at the moment, what I want to try is this Pandas cookbook. So originally, Open-FDD was the Pandas computing library. So that's a Python analyst analytics computing library, great for tabular data sets for rule-based fault detection. And that is no longer inside Open-FDD because it's converted to 100% Rust now, but the cookbook is still there for the Pandas computing library. So this is what I want to demo, how to run this outside of Open-FDD, but there's still a cookbook there for the Pandas computing library. So these two, there's SQL cookbook and the Pandas cookbook, and they both should be mirrors of each other. So like, for example, this one is just like how a rule would be written in SQL. So this would be just like some kind of a rule for when the outside air temperature is greater than 40 and less than 110 degrees Fahrenheit assumption. This is what an SQL rule would look like. And then in Pandas, we would have some Python code. So it kind of looks like this. These are Pandas data frames, and AI is actually really good at writing code in Pandas, also in SQL. So like what I'm going to task ChatGPT to do is I'm going to give it this URL for the cookbook and then all of these existing fault detection rules. So what I have a historical data set, which I'll show you in a second, is so I'm just going to want to run some like real basic, I might even actually do these all in links. So These are just like very generic fault rules: stale data, flatline stuck sensors, mixing between the mixed air temperature sensor and outside air temp return temp, humidity sensors out of range. So basically, it's very, they're just kind of generic fault detection rules. There's one for air handling units. So this is ASHRAE Guideline 36. Duct static pressure is low when a variable fan system is at full speed. Mixing air temperature sensors. So I'm going to ask ChatGPT to do everything. This is fault condition 4 defined by ASHRAE Guideline 36. So like what it does is it looks at an hour's worth of data, and then it calculates that if the air handling is in a heating mode, cooling mode, just a fan only mode, or an economizer cooling mode, by looking at this is the outside air damper percentage, fan command, cooling valve, heating valve. So it's looking at positions in the data to determine which mode that the air handling unit is in. And if there's ASHRAE Guideline 36 defines how many state changes that you can be in, that the air handling unit should be going between heating mode, cooling modes, back to economizing, back to, so it's state changes allowed per hour, which I think is 5. So if the air handling unit is oscillating in between these different modes by valve positions, damper positions, in the data, it's going to flag it. And some of the stuff is too, it happens so slow, even PID huntings happen so slow that you can't really see it in the live system unless it's very blatantly obvious PID hunting. So this should be a form of PID hunting. And I just thought like we should also have a generic PID hunting rule too. Fault condition 5. So I want to run all of these except for this one. This one's kind of a more advanced rule that you need design CFM, design airflow volume for the air handling unit, which I don't have. So yeah, so there's actually a huge mess of information here that we should be able to feed into the AI agent. Leaking coils. Another thing, yeah, so let's just kind of work with some of this and just see what it does. Economizer, and it's economizer should be economizing when it's not. So like there is rules written in Python for this. Even weather station data, which we should be comparing web weather to local sensors too. I'm also doing by default a 300 seconds or 5 minutes delay. So like when we run the rules across the historical data, that there needs to be a 5-minute delay, which is an adjustable parameter, before flagging that as a rule that's true. It's like a delay parameter, just to try and weed out some false positives. So yeah, a whole bunch of stuff here. So let's try and I'm just going to feed in ChatGPT here and tell it to look through all of this sub-tree of information here. So maybe I'll just start with, let's just go to a blank ChatGPT, and I'm just going to ask it, can you see this subdirectory of Open-FDD docs? And I'm just going to say, please soak in all this info, and what I am focused on today is the pandas outside of Open-FDD with CSV files. The Pandas Cookbook. Particularly this info. Okay, so I just pasted the link. Got some really bad spelling. So like another thing with AI these days is you can give it links and it could just go fetch that data. Okay, so we're gonna give that to ChatGPT. It's gonna think. I'm also on the 5.5 model, and I don't know if this makes a whole difference or not, but as long as I'm on the latest and greatest model is what I want. Yes, I can see it. Okay, so we're gonna ask ChatGPT to. Okay, so it's already creating some stuff, which is nice. So it's gonna go nuts trying to look at some historical data. Okay, so then what I want to do is this is some historical data that I have here. There's actually two buildings. So this is so two buildings. They're both variable volume air handling unit systems, and I downloaded some weather data from openmedio.com. Maybe we should just look at that real quick. So this is Open-Medio. So this is cool. So this is free. Like you don't even need an API key or anything. Like you can download historical data and current sensor readings too. Maybe it's just the US, but apologize if people are from outside of the US, but try and find a way to get historical weather data. But Open-Medio is pretty cool. Maybe it's this one. Sorry, I might have been on the wrong website. So it's this website, Open-Medio. Yeah, this is amazing. That this is a free place to get weather data. Cool. And it looks like there's subscription plans to get more data, but I was able to download. So I have like about 6 months worth of data, the historical data that I downloaded from these buildings, and then I was able to just tell ChatGPT. Actually, I did this with cursor agents to make Python code to download another Excel CSV file of historical weather data for relative humidity, dry bulb, wind speed, and dew point for this particular location. Okay, so let's just go over this. I just want to focus on one building at a time. I have two buildings, the 100 building and the 50 building. Just like looking at some of these plots there, it's a real basic building. So it's just a building in Midwest USA, like very hot summers, and this particular location will have very cold winters too, with high humidity in the summertime conditions like we are in now. So it's just an older VAV system, 2 air handling units feeding 6 floors. Nothing very fancy, just classic VAV systems with very looks like just ordinary air handling units with 1.65 inches of duct static pressure. So this is the duct pressure sensor right here. This is the variable fan with the VFD speed, and then this is mixing air, just classic return supply fan, mixing temperatures, return air temperatures, space temperature. I wonder if that's an average space temperature, and then leaving air temperature, cooling valve positions, and I think the VAV boxes have reheat coils. Same thing for the air handling unit 2. Boiler system. The building must be old enough that it's not even a variable pumping system. And then there's a mixing valve for the hot water supply set point. And then the chiller plant just looks to me like 2 air-cooled chillers and an outside air enable set point of 55. So to me, this is a red flag right here, is that we can technically be free cooling on the air handling unit systems for sure at 55 degrees Fahrenheit. So maybe I'm going to ask the AI agent to kind of go over these set points on the graphics here, and then see if it sees any anomalies in the data that that we technically would like to see that, bumped up, if you could get away with it, to 65 degrees Fahrenheit, and then that would save you some mechanical cooling runtime on these guys. Unless there's some performance degradation of the air handling units that it can't quite deliver that cooling load, that could help save on some energy bills a little bit. Okay, so this is all the screenshots I have. So, and then what I asked the AI agents to do is this data, when it was downloaded, it was very messy data. And I asked the AI agents in Python to iterate until I can plot on a pandas data frame. So that is basically a pandas data frame is kind of, think of it as an Excel spreadsheet, that if you can plot the data, that the data in theory should be clean enough to start running fault detection rules. Just looking at this data, it looks like there's a lot of flatline sensor stuff going on. This zone, looks like this zone right here, holds set point very well. And something gnarly happens over here. Of course, these axes might be a little bit different. Couple of sensors reading 0. So I have a feeling like we're going to have tons of false positives. Let's just try this out. I think it'll work, and it'll at least give us something useful. So that's the 50 building, and I kind of wanted to start on the 100 building. All right, so I think like what I want to do is just zip all this and give it to ChatGPT. Okay, so I'm going to zip all that. And just load that into ChatGPT. And okay, let's just start going. It's really tempting to just give it a really big loop, or see if it can start. Okay, so gosh, what should we do? Maybe we could just do a loop. So I think that's the latest and greatest. Like we could just be doing prompts. Prompt, which I think we'll end up getting back into at some point anyways. But maybe we could just try and engineer a loop, if I'm just saying this correctly. Okay, so I'm gonna say, I just have a text file open here. Say, please unzip this and check out the data. There is a building 100 and a building number 50. Let's look at the building 100 and start running FDD equations defined in the Open-FDD Cookbook for pandas. What should we do? Just visualizing the data. There appears to be lots of flatline sensors. Okay, so let's see. Maybe we could just start with, I'm going to go back to here. I'm just going to do here. So I'm going to say, you can actually copy these little icons right here, and it'll give like an exact URL. Can you start with this? Actually, I'm going to give it this URL. I accidentally linked it this sensor validation. Let's say, please run this across all zone temp sensors for sensors out of range. What we want to do as well is rank all of these sensors for performance of, let's see, I think the client said of a zone set point of 72F when the building is occupied from 6 a.m. to 5 p.m. Monday through Friday, and then let's see, I think they said 7 a.m. to 2 p.m. on Saturday and closed on Sunday. I'm going to say what we need here is classic RCX style of reporting, where you should have enough data to do actually, I think we may not have a end of heating season, spring free cooling economizer season, and then full mechanical cooling for the months of June and July. Break the reports down into these 3 different seasons. Okay, let's see. I'm going to shoot for zone set point, or zone set point performance, broken zone sensors, VAV box, broken airflow sensors, VAV box, air damper, and reheat valve hunting. Please make a rule that you can use with the Pandas computing library to know when a valve is hunting back and forth. Let me go back here. This should be kind of similar to here. This PID hunting fault condition 4 by Action Guide 36. This could be similar to FDD guideline 36, number 4, outputs and reheat valve commands. Let's see, what else could we do with a VAV box? So if there might be some mapping, there may be mapping to the air handling unit in VAV box. There may be mapping to the VAV box and AHU, which feeds and fed by relationships exist, where you could attempt leaking reheat valve equations. I think that's good enough for VAV boxes. Maybe we should start there. Gosh, what should we do? Break the... I might do this, like VAV box, AHU, chiller, and boiler reports, each separate for each season. Please put reports in an HTML file, which I can open on my desktop, stand alone in the browser. So this is experimental here. So I want to see if ChatGPT can put all of this retro commissioning data in an HTML file and then do all of the cool analytics charts and everything in HTML, and then I'll just open it. You can open an HTML file on your desktop in Google Chrome, so it'll just be open, you know, it won't be served by a web app. I think this should work. Please put in a standalone HTML file, or I guess I can serve it with Python built-in develop server for serving HTML, but make nice analytics charts and reports. Do nice JavaScript for, yeah, I mentioned charts already, charts. Yeah, what kind of charts we could do? I'm just gonna say, wow me for analytics and cool charts. Okay, so that is VAV box. I'm just gonna say like this, VAV box. Let's see, HU. So I'm just gonna say, please. I got that little tab. That was kind of cool. Please use the fault conditions for an AHU. Please find rogue zones. Let's see. So please find fault conditions for AHU. Please find rogue zones. Please find HU systems running outside of operating hours when zone air temperatures are satisfied. So basically, if the building is unoccupied, you can save mechanical cooling energy by not running the air handling unit systems. I'm just going to say use typical AHU faults for economizer performance, etc. In winter, please flag economizing and VAV reheat operations and mechanical cooling season. It would be economizing outside of ranges. Oh, what could we do? So I'm just gonna say, I notice on the chiller plant plots that the air-cooled chiller set point is low to enable the chiller. So there may be some analytics of when we could be using free cooling instead of mechanical cooling. I feel like I'm giving this probably enough. So I'm going to just give this air handling units, just give it a link here. Please comb through the, might be one for central plants. Oh, there's one for VAV zones too. I will give it that too. Central plants. I'm just going to give it, this is probably enough. Move through the central plants and find good info with that as well. Give it a description. The central plants appear to be very simple air-cooled chillers and a boiler hot water system. Okay, spelled that wrong, but okay. So then we could say, I'm just going to call it iterate until completed reports in WOWD HTML file style reporting, where you can give me a HTML and tell me how to serve it locally with Python, which is really easy. I can show you that. So in total, 3 in total reports for each season. 3, and each season will have a HU report for the 100 building, HU 1 and 2 systems, zone level analytics, and chiller and boiler. All right, let's just see what this does. I think this is plenty of info here, so I'm just going to copy that. For some reason, I think it's just easier in a text file. Okay, here we go. Gosh, it's so tempting to put this on agent mode in ChatGPT. Whether it does anything or not, I'm not really sure. So where's agent mode? I wonder if OpenAI has even got rid of agent mode. Huh. Maybe they even got rid of agent mode. Looks like OpenAI doesn't even have agent mode anymore. So I think they kind of have all this stuff built into the tools. So I'm going to just put this on high and then have it go. There we go. So not really sure how long this will take, but and how good it is. So if you are watching this YouTube video, I think it was actually did something useful. I'm not sure. So hope you guys are having a good summer in the Northern Hemisphere or the Southern Hemisphere. You're in probably winter, so it's very hot where I am now. So looks like you can see this stuff. It's doing a few things. What's interesting behind the scenes, it's like I love how you can see like the chatting. There's like appears to be a band of monkeys behind the scenes, asking each other questions. So I think like behind the scenes there's like an orchestrator agent, and then there's all these different worker agents, going on. I don't really know. It's kind of like a cool concept of AI engineering, I think. Maybe while this chugs away, I did do actually, what else is really cool about ChatGPT is I had it do deep research. So I pushed it quite a bit on all the existing Open-FDD documentation. But then when you do something in deep research, it can chug away on something for up to like an hour if it's some random topic, but it spawns up probably dozen of agents to comb the internet, and I had it comb the internet for anything it knows in fault detection where the expression rule cookbook is falling behind in Open-FDD. So the deep research of OpenAI is definitely put to the task of ensuring that this is pretty up to speed for fault detection equations. And these are just rule-based equations too. Nothing very fancy. I think some people get into this is beyond my pay grade. I've never experimented with it, but like machine learning based fault detection, where someday I want to play around with that, but I haven't done that yet. A little something on heat pumps, weather stations. Ooh, this is one thing we forgot to ask for. I just thought of is like there is open media data, and I think there's a local center as well too. I wonder if I can do this here. Please also include a fault rule in pandas for a local BAS weather sensor and the web weather from Open Media, where a fault would be if the local sensor is off by some tolerance, perhaps 3 to 5 degree F. I was going to say that. So cool. It's cool you can chat with it while it's still thinking. Oh no, 15-minute intervals. So we are in 15-minute interval. It would be nice to have 5-minute intervals and even 1-minute intervals if like you can, the more data you have, the better. 1 minute is more than plenty granular. Definitely never log your data, at least for HVAC fault detection purposes. I don't think less than 1 minute, just because it creates a ton of unnecessary massive data sets, I think. Unless you're doing like the internal workings of a chiller and refrigerant pressures or something, like 1 minute data is very high frequency. And 5 minutes is generally rule of thumb. You'll still get good data out of 5-minute intervals. 15 minutes, I just realized that is kind of, we should ask to have that reduced to drop it down to 5 minutes. And then if they have a Niagara server, which I think this building has, it's a Niagara building automation server, it's more than plenty. It can handle it. Please let me know when you are done. Assume it's still working. Okay. Okay, so I must be doing a little bit of work behind the scenes to build us some reports. Okay, so back to the, oh yeah, we do have some trim and respond. So this is something, variable volume air handling units. So yeah, lots of good stuff here. This might create an insane amount of false positives, but I think that's what we have to do, is put on our engineer cap and see if we can get it fixed. Let's say I don't see it, the icon spinning anymore. Please validate you are working on the reports. I don't see your spinner icon. Oh, there it goes.